In this video, we will identify a buffer from a mixture of conjugate acid, conjugate base pairs. So it's worth noting what the definition of a buffer is. It's a combination of a weak acid with its conjugate base. And this can resist wild changes in the pH. It sort of stabilizes the pH, where the best buffering capacity is where your pH is equal to pKa plus 1 or minus 1. That is where this realm, or in this window, you have the best buffering capacity. This is where the pH cannot go too high or too low, when the pKa plus or minus 1, when the pH is within that range. So once again, it is a conjugate acid and conjugate base combination. So we just look here between A, B, C, and D, which is a conjugate acid and which is a conjugate base. So KCl and HCl, KCl is potassium chloride, it's potassium ion and chloride ion. There's nothing conjugate about it. HCl is an acid, but we don't really have the conjugate base. Now you may say the conjugate base here is Cl, but remember, HCl is a strong acid, 100% ionization. A buffer has to be a weak acid, weak conjugate base configuration. You see, there's nothing basic about HCl. It's all acid. It's a strong acid. So it's not A. Part B is a different scenario. Here you have potassium ion. Again, forget the potassium because it's just what we call a spectator ion. But that HSO4 minus is a good conjugate to H2SO4. So H2SO4 is sulfuric acid, lose a proton and it becomes its conjugate, which is HSO4 minus, and henceforth you do have a good conjugate acid-base pair situation. So part B we would expect to be a buffer. Part C, again, sodium ion is just there to trick you. It is a counter ion, or what we call a spectator ion. And here we have HPO4 minus 2, and its conjugate acid is H2PO4. Okay, again, the sodium ion is just a spectator ion. So I predict C to be a good buffer, right? Because H2PO4 is the acid, HPO4 minus 2 is the conjugate base, and so that would be a buffer, would represent a buffer. Finally, there are no protons here. Potassium ion is potassium ion and nitrite ions. This is an acid, H plus, and nitrite, but you see nitrite is not a conjugate of H plus. And nitrite, or NO2 minus, okay, not a nitrate, but nitrite, NO2 minus, cannot give a proton and it cannot take a proton. Well, it could take a proton. If it does, it becomes HNO2, but it cannot give a proton. So there is no basicity involved in NO2 minus, just like there is no basicity involved in HCl. So D would not represent a good buffer. It is not a conjugate acid. It's not a conjugate base, because simply the NO2 cannot do anything, right? Same thing here. Cl minus, which is the conjugate of HCl, cannot do anything in terms of picking up protons or giving off protons. It can pick up a proton, that is correct technically, but it cannot give away a proton, so it cannot be involved in regulating pH. The best buffers here are B and C, simply because you have the HSO4 minus, H2SO4, conjugate acid-base pair. This can do some basic action, this can do some acidic action. Same thing with C. This can do some basic action, and this H2PO4 can do some acidic action.